Cool guys, so we have question 6 now. The sketch below shows the graphs of f of x equals a over x plus p plus q, and that is our hyperbola, and g of x equals negative x plus k, that is our straight line graph. The graph f of x cuts the x-axis at a, negative 8 and 0, and cuts the y-axis at b. The asymptotes of graph f intersect at point d, negative 4 and negative 1. The graph g passes through point d, very important, meets graph f at point C and point E, and then cuts the y-axis at point f as shown on the sketch. Okay, great. So what we need to do is we need to get the value of k for 6.1.1, only 2 marks. So k is over here. It is the y-intercept of our straight line graph, and they told us the asymptotes of graph f intersect at point d, negative 4 and 1, but graph g also passes through this point, which means we know that this point is on this graph. So we just need to sub in our x and our y value, and then we can get k. So when we plug it in over here, we have minus 1 equals minus 4 plus k, and if we simplify this, minus 4 becomes positive 4 plus k, and that is negative 1, and therefore taking the 4 over, we have minus 5 equals k. So now we have the value of k. We can write this over here. It is minus 5. And then 6.1.2, the values of a, p, and q, all of which are on our hyperbola. So p is our horizontal shift, which is our vertical asymptote, and q is our vertical shift or our horizontal asymptote. So this negative 4 and negative 1 are our p and our q. So I'm going to go ahead and plug them in. So y equals a is what we want to solve, x, and then our p value is this guy over here. But a reminder that p is backwards. So if this is negative 4 here, we have to make it a positive 4 when we plug it into our formula. And then q is this guy over here, and it is just negative 1. So we have minus 1. So we're almost there, done solving. We just earned 2 marks. The value of p is positive 4, and the value of q is negative 1. And then it means we need one other point on this graph in order to solve for a. And we do. We have the value a equals negative 8 and 0. So we make 0 there. We plug this in. We have minus 8 plus 4 minus 1. And then we can go ahead and we can solve for this. So take the minus 1 over, becomes positive 1. We have a equals negative 8 plus 4 is negative 4. And then we times this guy up. We have minus 4 equals a. We're in quadrant 2 and 4, which means we should have a negative value, as that places us in the correct quadrants. Great. So we have just calculated for the values of a, p, and q. A is negative 4, p is positive 4, and q is negative 1. Cool guys, so question 6.2, what we have here is determine the values of x for which f of x, this graph, is greater than or equal to g of x. So if we are going to look at it in interpretation first before we start to solve for it, what this means is where is f of x on the x-axis greater than the g of x in terms of y. So if we're at this point, our hyperbola, our f of x, is less than our straight line. But as we move to point C, they're exactly equal at that point. And then as we cross there from C all the way to our asymptote, our f of x is greater than our g of x for this whole range here. So that is point 1. But once we've crossed our asymptote, our f of x starts down here again, which means it is below our g of x up until point E. But as soon as we're past point E, our f of x is greater than g of x for the rest of that range, going up until infinity. Because this graph will keep going down and this graph will keep going up, but never hit the asymptote. So we can go ahead and we can plug it in the inequality, but that might be hard to interpret. The easiest point, now that we've established what the range is from here to here, and then any point from here or greater than, what we're trying to do is we're trying to get the c and the e value. That's why it's 5 marks, because it is a simultaneous equation. So our f of x equals negative 4, because it is quadrant 2 and 4, x plus 4 minus 1. This is what we solved in the previous question, the values of a, p, and q. And we made this equal negative x minus 5, because we solved the negative 5 for the k value for our g of x graph. So at this stage, when we solve it, I'm going to take the negative 1 over. We have minus x and we have minus 4, because minus 1 becomes positive 1. So we have negative 4 there. Then we have minus 4 over x plus 4. So now that we're here, what we need to do is solve for it. So I'm going to take a negative out here just so that we end up having the exact same form in our right side and our denominator. So at this stage, if we're going to LCD it, we're going to times our x plus 4 up here, which makes this whole thing x plus 4 squared. Cool. And this is -4 because we have gotten rid of the denominator. So here, what we're going to do is divide by a negative on both sides. So we have 4 equals x plus 4 squared. And then at this stage, we can go ahead, we can FOIL this, take our 4 over, and then we can factorize in order to get the actual x values for c and e over there. So x times x is x squared, 4 times x is 4x, times 2 is 8x, 4 times 4 is 16, and then minusing 4, taking this 4 over, we have that equals 0. So then we can simplify this, x squared plus 8x plus 12 equals 0. And then opening up the brackets, we have x in one bracket, x in another bracket. The factors of 12 are 1 and 12, 2 and 6, 3 and 4. And 2 and 6 will give us the 8 over here. So we have plus 6 and we have plus 2. So now that we have these values, we have x equals -6 and or x equals -2. So -6 and -2 is over here. So we have -6, which is our c value. So -6 and something, and e is -2 and something, question mark. Okay, now at this stage, we can just interpret our equation because they want where's f of x greater than or equal to g of x. So this was -6. So it is anywhere that is greater than -6, but less than 4, because our asymptote is the restriction here. So it is anywhere between -6 or including -6, because that point is included. X is here, and then -4, but we can never touch -4 because it is the asymptote. So it'll go as close as it can, but it will never actually touch -4, so we do not include it there. But we are not done. We've only dealt with one component or one part of this thing. The other range here has to do with this -2 over here by e. It is any value that is equal to or greater than -2. So x is greater than or equal to -2. Because as we move there, -2 is included, and then anything greater than -2 will also be true for f of x being greater than g of x. And those are our answers. So now we have determined the values of x for which f of x is greater than or equal to g of x. And then 6.3, a graph represented by hx equals x, so there's a positive gradient, +1, plus t, so we don't know the y-intercept of this graph, is drawn on the same set of axes as f and g, for which values of t will graph h be a tangent to graph f. So at this stage, a tangent to graph f will be something that only hits this point once. So we have a line going through there. Imagine that hit just at point C, because that's what a tangent does. It only hits without crossing through. If we were to shift it up a bit, it would cross through twice, and that is not a tangent. And then same thing here. At this point E, it would be the point that is hitting there just once. So it is 6 marks. We just need to determine what the t value is, like the range or the exact points makes the statement true. Because a tangent cannot go through the points twice. So it means it has to hit point C here, and it has to hit point E here, because those are the maximum points. So we just need to interpret or see what the values of t will be. We can't eyeball it, we can't just inspect. It's not going to be necessarily 0, and it's not going to be whatever this value is, but we have to calculate it to figure out what the t value shift will be in order to make the statement true. So for which values of t will graph h be a tangent to graph f? Okay, so what we need to do is we need to make these guys equal each other. So graph f is -4x plus 4 minus 1, and then this guy is x plus t. When we have a tangent at this stage, we are going to do something with roots. So we're making them equal because we know that these points hit at least once, and then we're going to do something with the roots in order to solve for t separately. So first we have to times everything up. So each term needs to get x plus 4 so that we can drop the denominator. So we have -4 here, we have minus x minus 4, I've just distributed there, minus x minus 4 equals x plus t, x plus 4. So -4 minus 4, so we have minus x minus 8, and then we have x squared, x times 4 is 4x, x times t is plus xt, and then t times 4 is plus 4t. So at this stage, we want to take everything over to one side. So we're going to take it over to the right where our x squared is positive. So we have x squared here plus 4x, and then minus x, we take that over, it becomes positive 5x. We're going to have plus xt, we're going to have plus 4t, and then we're going to have plus 8, taking this -8 over, making it positive. So this all equals 0 here. Okay, so now that we've taken everything over to the side, what we need to do is we need to get it in some sort of standard form. So this x squared, there's nothing to do here, but these middle two terms here, 5x and xt, we can factorize a common x out. So what we have is we have x here, and what we're left with is 5 plus t. That is good for us, and then this 8 plus 4t that can live over there. Because what this means is that our a value is 1 over here, our b value, the guy that is attached to our x, is this over here, and our c value is this whole thing over here. Because now we have an a, a b, and a c that we can plug into our root question. So graph represented by hx equals x plus t is drawn on the same set of axes as f and g. We know that this is some sort of equation that represents them. And now for which values of t will the graph h be a tangent to graph f? The fact that it is a tangent means it only equals once. And then as far as a delta, it means we're just going to make delta equal 0 because it only equals once. It's not greater than, there's no range. We're just trying to calculate what value of t will be true for here, for the y-intercept, and for this guy over here. So what we need to do is we made it equal 0, not less than 0, not greater than 0. And then our equation is b squared minus 4ac. So our b value is this 5 plus t over here, minus 4, and then a's value is 1 over here. C's value is 8 plus 4t. Great. And now that we've plugged this into delta equaling 0, we have the values for t that we can solve for, which means it's going to be some type of quadratic because there will be two values that satisfy this equation that work for the tangent of this graph. So that means 5 times 5 is 25, 5 times t is 5t, times 2 is 10t plus t squared. So minus 4, 4 times 1 is just minus 4, and then we can distribute the 8 plus 4t on the next line. So 25 plus 10t plus t squared, I'm just going to put this in standard form so long, t squared plus 10t plus 25 minus 4 times 8 is minus 32, and minus 4 times 4 is minus 16t. Great, so we can simplify this. T squared plus 10t minus 16t means we have t squared, and then we have plus 10t minus 16t means we have minus 6t, and then plus 25 minus 32 means minus 7. So here, once we have factorized this, we're going to open up our brackets. We have t in one bracket, t in the other bracket. The only factors of 7 are 1 and 7, which means we have 7 and 1. And then we have a minus 6t here. So we have a minus 7 and a positive 1 over there. And then at this stage, we have t equals 7 or t equals minus 1. Cool. And those are the values for t that satisfy this equation. Which values of t will the graph h be a tangent to graph f when t is minus 1 over there and when t is positive 7. Great, guys. So that is question 6. Let me know if there are any questions in the comments below, anything else that you guys need help with, and otherwise I will see you in the next video.